In recent years, the global automotive industry has been undergoing a transformation on a scale that until recently seemed impossible. Just 5 to 7 years ago, Chinese cars were perceived as a compromise option, often inferior in quality, technology, and prestige, compared with Western and Japanese brands. But today, the situation has changed dramatically, and according to analysts from leading consulting agencies such as McKinsey and Bloomberg Intelligence, China has not simply caught up with its competitors. It has started setting new rules for the entire industry. Chinese automakers have rapidly transformed into technological leaders, setting the pace for the development of the entire sector. And now, after the electric vehicle segment has been almost conquered, Beijing is taking the next step, a far more ambitious one. According to sources close to Chinese government circles, the country is discussing a new long-term strategy for the development of future transportation, where the key direction will be the integration of ground and aerial mobility. The idea involves creating hybrid vehicles capable not only of moving on roads, but also of taking to the air, covering thousands of kilometers without being tied to traditional infrastructure. This concept has already received the unofficial name three-dimensional mobility and is being considered as the next logical stage after mass electrification. Against this background, BYD is once again at the center of attention, one of the largest players in the global electric vehicle market and an undisputed leader in battery technology. Just a few years ago, BYD remained in the shadow of names like Tesla and Volkswagen. But today, it not only competes with them, but confidently surpasses them in certain segments. The company controls the entire production cycle, from battery development to vehicle assembly, giving it a unique advantage in the race for the transportation of the future. According to information published by several Chinese technology media outlets and confirmed by industry insiders, BYD has already begun laying the foundation for entering the flying transportation segment. This is not yet about a finished product or an official announcement, but sources claim that the company is actively investing in research into lightweight composite materials, highly efficient electric motors, and vertical takeoff and landing systems. All of this is directly connected with eVTOL technologies, electric aircraft that are considered the foundation of future flying cars. Experts note that the transition to flying transportation could radically change not only the automotive industry, but also global logistics as a whole. Imagine a world where the distance between cities no longer matters. A journey that today takes 5 to 6 hours by car could be reduced to 40 to 50 minutes through a direct aerial route. Mountains, oceans, deserts, and megacities would cease to be barriers. Transportation would move along the shortest trajectory, bypassing traffic jams, infrastructure limitations, and geographical obstacles. For China, this opens enormous opportunities. A country with a vast territory and dense urbanization would gain a tool capable of connecting remote regions with major cities with almost instant accessibility. According to Goldman Sachs analysts, the introduction of aerial mobility could increase the efficiency of China's domestic economy by tens of percent through faster movement of people and goods. However, behind this futuristic vision lies an extremely complex engineering challenge. A flying car is not simply a vehicle with wings. It is a hybrid of two systems with completely different requirements for safety, reliability, and control. It must be light enough to take off, but at the same time strong enough to withstand road loads. Its power system must provide vertical takeoff, horizontal flight, and road movement, all without losing efficiency. Batteries play a critical role here, and this is precisely where BYD has a major advantage. The company is one of the largest battery manufacturers in the world and is actively developing its own technologies, including solid-state batteries and new types of chemistry with increased energy density. According to experts, battery energy density remains the main limitation for the mass adoption of flying cars. For such transportation to become a reality, it must provide sufficient flight range while maintaining minimal weight. Another important aspect is safety. Unlike conventional vehicles, a system failure in the air could lead to catastrophic consequences. Therefore, developers are forced to implement multiple layers of redundancy for all critical components, from motors to control systems. This significantly increases the cost of development and production, which automatically makes the first flying car models extremely expensive. According to preliminary estimates, the price of the first mass-produced models could reach $300,000 to $500,000 per unit, making them available only to a limited group of customers. However, just as with electric vehicles, experts expect prices to gradually decline as production scales up. Another major challenge is regulation. The introduction of flying cars requires the creation of completely new infrastructure, from dedicated air corridors to urban air traffic management systems. Governments will have to develop new safety, licensing, and certification standards. In China, this process has already begun, and according to insiders, the government is considering creating pilot zones where testing of such vehicles will be allowed. Interestingly, BYD is not the only player in this race. Companies such as Xpeng Aero HT have already demonstrated working prototypes of hybrid transportation systems capable of separating the flight module from the ground chassis. Nevertheless, analysts believe that BYD's scale and manufacturing capabilities could allow the company to bring the technology to the mass market faster than others. According to forecasts from industry experts, the first limited versions of flying cars could appear by the end of the current decade, while mass adoption is not expected before 2035 to 2040. By that time, battery technologies, autonomous driving systems, and aerial infrastructure will need to reach the required level of maturity. And if these forecasts prove correct, humanity is standing on the threshold of a new transportation revolution, one comparable to the emergence of the automobile or the airplane. And it is entirely possible that one of the main drivers of this revolution will be China, a country that in just one decade has transformed from a follower into a technological leader. And, as analysts point out, if the world once asked whether China could catch up with the West, today the question sounds different. Can the rest of the world keep up with China in the race toward a future where roads are no longer limited to the ground and transportation rises into the sky, opening a new era of mobility? And as this concept begins moving from theory into practical implementation, the industry is increasingly asking not, is this possible, but rather, who will do it first? Within the Chinese technology community, the belief is growing that the window of opportunity for a breakthrough is open right now. Several factors have aligned at once: the rapid development of artificial intelligence, progress in autonomous control systems, a revolution in battery technologies, and unprecedented government support for innovation. Sources close to the research divisions of Chinese corporations claim that the largest automakers are already conducting closed tests of individual components for future flying platforms. These are not complete vehicles yet, but key modules, stabilization systems, thrust distribution, intelligent autopilot capable of controlling a vehicle in three-dimensional space. Essentially, a new transportation ecosystem is being created, where a car stops being just a means of transportation and becomes an autonomous flying module with a wheeled base. Artificial intelligence plays a special role in this process. Manually controlling a flying car is a task that requires pilot-level skills, which automatically limits the mass adoption of the technology. That is why developers are focusing on fully autonomous systems that will take over the entire process, from takeoff to landing. According to analysts, without powerful AI, large-scale implementation of flying cars would simply be impossible. In this context, the strategic logic behind the actions of companies such as BYD becomes clear. Even if today they are not presenting finished prototypes, they are actively investing in related fields: batteries, electronics, power systems, and software. This creates a technological foundation that can later be quickly converted into a complete product. Essentially, a hidden preparation for the next technological leap is already underway. Insiders also note that China views flying transportation not only as a commercial opportunity, but also as an element of future national infrastructure. Inside the country, projects involving vertical cities are already being discussed, where building rooftops would serve as landing platforms, and movement between districts would take place through aerial routes. This completely changes urban architecture and the principles of city planning. But the closer this future becomes, the more clearly new risks begin to emerge. One of the key challenges is air traffic management. If thousands or tens of thousands of flying vehicles simultaneously take to the skies above a megacity, an entirely new coordination system will be required, capable of tracking and managing every object in real time. This is a national security level challenge, requiring enormous computing power and highly reliable communication networks. Another critical factor is public perception. Despite technological progress, many people still view the idea of flying in autonomous vehicles without pilots with skepticism. Any incident, even a single one, could seriously slow down the adoption of the technology. That is why companies working in this field are placing enormous emphasis on testing and demonstrating the safety of their solutions. Interestingly, alongside the development of flying cars themselves, a battle for standards is also taking place. What will the control interface look like? Which communication protocols will be used? How will vehicles from different manufacturers interact with each other? These questions are currently being actively discussed at the level of international organizations, and the answers will determine whether the industry can develop globally or remain fragmented. Experts also emphasize that the first real use cases for flying transportation are unlikely to appear in the mass consumer market. Instead, they will most likely emerge in specialized scenarios. These could include emergency services, medical evacuation, delivery of critical cargo, and corporate transportation. These areas can justify the high cost, while the advantages of the technology are most obvious. And only after that, as the technology becomes cheaper and experience accumulates, will it gradually begin to enter everyday life. This is exactly how it happened with the internet, smartphones, and electric vehicles. First, an innovation for a select few, then a standard for everyone. That is why many analysts believe that we are at the very beginning of a new technological wave, a wave that could completely change the way we think about distance, speed, and accessibility. And if today this sounds like a futuristic scenario, tomorrow it could become a new reality. And in this reality, roads will no longer be limited to asphalt. They will rise into the sky, becoming an invisible network of routes connecting cities, countries, and continents. And the companies that are laying the foundation for these technologies today will be the ones that determine exactly what the transportation of the future will look like. Against the backdrop of the rapid development of these technologies, a new line of competition is beginning to form within the industry, one that goes far beyond the traditional automotive market. It is no longer simply a battle for customers or market share. It is a battle for control over the infrastructure of the future. Whoever creates the first working, scalable flying transportation system will essentially gain the key to managing a new era of global mobility. And this is exactly where China, according to a number of Western analysts, may find itself in a unique position. Unlike the United States and Europe, where the adoption of such technologies often faces strict regulatory barriers and lengthy approval processes, China is capable of moving much faster. The government can centrally allocate resources, define priority areas, and launch pilot projects within short timeframes. This gives Chinese companies a powerful advantage in the race for technological leadership. According to information leaked to specialized technology media outlets, several Chinese provinces are already considering projects to create so-called aerial corridors, specially designated zones where autonomous flying vehicles will be allowed to operate. These corridors could become the first prototypes of future air roads, through which thousands of AI-controlled devices will move. The issue of energy deserves special attention. Flying transportation requires significantly more energy than traditional vehicles, meaning charging infrastructure must evolve to an entirely new level. Concepts of vertical charging stations are already being discussed. Facilities integrated into buildings where vehicles will not only land, but also rapidly recharge their batteries. In the future, this could lead to the creation of entire networks of aerial hubs, similar to modern airports, but distributed throughout cities. At the same time, some experts believe that battery technology will become the main factor determining the speed of industry development. Despite major progress, current batteries are still limited by energy density, which directly affects flight range and duration. This is why companies like BYD, with their own developments in this field, are in a strategically advantageous position. Insiders claim that research is also being conducted into alternative energy sources, including hybrid systems and even hydrogen-based solutions. Although these technologies are still at an early stage, they could play a key role in the next phase of flying transportation development, providing the necessary balance between power, range, and safety. Noise is another important factor. The mass use of aircraft in urban environments will inevitably increase acoustic pollution, which is already raising concerns among urban planners. That is why developers are focusing heavily on creating extremely quiet motors and improving aerodynamic efficiency. Some prototypes use multi-rotor systems with distributed propulsion, allowing them to significantly reduce noise levels compared with traditional helicopters. Another aspect receiving increasing attention is cybersecurity. A flying car controlled by artificial intelligence and connected to a network becomes a potential target for cyber attacks. Any vulnerability could lead to serious consequences, which is why developers are forced to build multi-layered protection systems, including data encryption, autonomous emergency modes, and rapid response mechanisms. Meanwhile, financial markets are already showing early signals of growing investor interest in this sector. Venture capital funds are actively investing in eVTOL startups, while major corporations are exploring strategic partnerships and acquisitions. All of this indicates that the industry is approaching a period of large-scale growth. But perhaps the most important question that concerns everyone is the timeline. When will we see the first truly mass-market flying car? According to expert estimates, the next 5 to 7 years will be a period of active testing and limited deployments. The first commercial routes will likely appear, most probably in the form of premium services or corporate transportation. Only after that will a gradual expansion of the market begin. Some analysts go even further and argue that by the middle of the next decade, flying cars could become as common a part of urban life as electric vehicles or ride-sharing services are today. Of course, this depends on many factors, from technological breakthroughs to political decisions. But the very fact that such a scenario is being seriously discussed already highlights the scale of the changes underway. And if we combine all these elements, technological progress, government support, investment flows, and growing public interest, it becomes clear that the world is indeed moving toward a new era of mobility, an era in which the boundaries between land and air are gradually erased, and transportation becomes truly three-dimensional. And perhaps, when we look back 10 to 15 years from now, it will be precisely this moment when major companies began seriously considering a shift into the air that will be seen as the starting point of a new transportation revolution that changed not only how we move, but also how the world itself is structured. But even if the first mass-market flying cars appear later than forecast, the overall direction of development is already becoming almost unquestionable. Today, the world's largest manufacturers are investing not so much in a specific future vehicle model, but in the underlying technologies without which this market simply cannot exist. Artificial intelligence, next-generation ultra-fast communications, new generations of batteries, lightweight composite materials, and high-precision navigation systems. All of these fields are advancing in parallel and gradually forming a single technological ecosystem. That is why many specialists compare what is happening to the beginning of the space race in the last century. Back then, it seemed impossible that humans would regularly travel into space, yet within just a few decades, technology made a giant leap forward. Today, a similar process is unfolding in the transport sector. The difference is that this time it is not about isolated breakthroughs, but about the creation of a new everyday infrastructure, potentially accessible to millions of people. At the same time, it cannot be ruled out that the first mass solutions will look very different from what we imagine today. Perhaps they will not be classic cars with fold-out wings at all, but compact autonomous capsules capable of automatically switching between road and air travel. Modular transport systems are also possible, where a ground platform connects with a flying module only on certain segments of a route, and such concepts are already being explored by engineers at several companies. Another important point is that aerial mobility could transform not only how people move, but also the structure of urban economies themselves. If travel time between major cities is reduced significantly, Real estate markets, logistics systems, business organization, and even labor markets will change. People will be able to live much farther from their workplace, while companies will be able to distribute production and personnel more efficiently across regions. At the same time, experts remind us that no technological revolution happens instantly. Electric vehicles also began as expensive niche products with limited infrastructure and widespread skepticism. Yet today, they have become a normal part of the automotive market. And in some countries, EV sales even surpass internal combustion engine vehicles. This experience leads analysts to view the prospects of aerial transport with cautious optimism. For companies like BYD, the current stage represents an opportunity to secure leadership not only in electric vehicle manufacturing, but also in shaping an entirely new segment of global industry. If the company truly succeeds in combining its achievements in batteries, software, power electronics, and autonomous systems into a unified product, it could secure one of the key positions in the future market. Therefore, today the main question is no longer whether flying cars will become part of our lives. The far more important question is how quickly technology can overcome existing limitations, and how prepared governments, cities, and society will be for such a large-scale transformation.